To start this question, let's expand out 5r minus 2 all squared. And that's going to give me 25r squared minus 20r plus 4. Now we're using the standard results for summations. So what that means is we're going to use the sum of r squared and the sum of r and the sum of 1. So we can write this summation as 25 times the sum of r squared minus 20 times the sum of r plus 4. So using our summation formulae, this gives me 25 over 6 times n plus 1, 2n plus 1, minus 20 over 2, n plus 1, plus 4n. Now we know we want a factor of 1 over 6n to come out of this, so let's start by taking that out. So let's take out 1 over 6n. That's going to leave me for this first bracket here with 25 times by this bracket expanded out, so 2n squared plus 3n plus 1. This, if it was over 6, would give me 60, so I've got minus 60 times n plus 1. And 4 on its own would be 24, so we're left with 24 here. So we've expanded out the bracket, we've got this factor here. We know we want a quadratic factor, so let's now simplify what we're left with. This is 1 over 6n. This is going to give me 50n squared plus 75n minus 60n is going to give me plus 15n plus 25 minus 60 plus 24 is minus 11. And that's written in the form that we were asked with. The next part of the question is saying that hence, that means we need to use our answer to part A in order to answer part B. So to do that, we're going to be writing that the 1 over 6k times 50k squared plus 15k minus 11 is equal to 94k squared. And we've done that because we've noticed that the limit now is k and not n, so we're substituting in k where we had n squared before. This will give me 50k squared plus 15k minus 11 equals 564k, and I'm able to have cancelled one of the k's there because I know that k is not equal to 0. This gives me 50k squared minus 549k minus 11 equals 0, which factorizes into 50k plus 1, k minus 11. And we know that k has to be positive, so because we know that k is greater than 0, then that means that k equals 11.